Let F be a continuous vector field with a domain that contains oriented surface S with normal vector n. The surface integral of F over S is equal to the integral of F dot ds equals the F dot n ds. And it says just below, therefore, to compute the surface integral over a vector field, we can use the equation F dot n ds equals the integral of F when we plug in the RUV dotted with TU cross TV of dA. Okay, and it says below, for the following exercises, evaluate the double integral of F dot n ds for vector field F, where n is an outward normal vector to the surface. So this outward normal vector, that means it has to be pointing out of the surface. That vector has to go in that direction, that normal vector. And then 285 says this, fxyz equals xi plus yj. And S is hemisphere. Z equals the square root of 1 minus x squared minus y squared. So the first thing I see here is when I'm dealing with this surface here, I want to parameterize it, so I want to get this RUV for it. So what I see here is if I square both sides, I'm going to get z squared equals 1 minus x squared minus y squared. And if I move those over to the other side, like I want to, that's going to give me x squared plus y squared plus z squared equals 1. So this is really a sphere of radius 1. So what that tells me here is I'm going to want to use spherical coordinates. Also keep in mind, since z was square rooted here, that means we're only looking for the positive z's, which means we're going to be above the xy plane, and that's what we're looking at here for that surface area. All right, so there we go. So we're going to need the spherical transformation equations. Now what we're going to do is we're going to find this UV. I should say this RUV. So the first thing we notice here is that my rho is 1, so I'm just going to write it up top here. Rho equals 1. And because that radius is 1, or yeah, the radius is 1 here. So anyways, so now we have our u and our v. So my u is going to equal phi, and my v is going to equal r. And there we go. We're all set and ready to roll with this thing. Oops, phi, not r. Theta. Okay, now we're ready to roll with this thing. Make sure we keep them straight. That's the biggest. Okay, so then for the first one, this is going to be a 1, and then sine u cos v. So I'm just going to write that in there. Sine u cos v. And then for the second one's my y there. So that's going to be sine u sine v. And then for the third one here, that's going to be cosine u. So there's my RUV that we're going to use here. And here we need to do a dot product, so we're going to have to get that TU cross TV next. So we need the space to get that out of here. So here's my RU. And my RU is going to be cosine u sine v. Oops. Cosine v. There we go. Okay, and the next one is going to be cosine u sine v, and then the last one is going to be negative sine of u. So there we go. Now let's try the RV next. So for the RV here, that's going to be negative, sine u sine v, and then for the middle one there, sine u, sine u cos v, and then for the last one here, 0. Okay, so there's our two vectors here, my RU and RV. Now let's cross them. So when we cross them, we're going to get our I, J, K here, and we're just going to run through them. So now for the first one, I'm going to get sine squared u cos v. And then for the middle term, I'm going to get that 0 again. And don't forget to negate it. I always keep forgetting that. So I'm going to do that 0, and that's here and here, times the corners. So negative times negative is positive. So that's going to be sine squared u and sine v. And then the last one here, is that last one going to be a long one? It is. We're going to get long again. So I'm just going to write that one out. And then we can clean this up a little. If you notice here, on the end here, they have a sine u, cos u, and they have a sine u, cos u. If I pull that out of both of those, I get a cosine squared plus sine squared. So that gives me a 1 times the sine cos u. So I'm going to get a sine cos u on the end. So there's our cross product then, simplified as much as we can. So now we're going to dot that with the vector field when we plug in our RUV. Oh, I forgot one thing here. Notice here I got a negative sign. I never negated my middle signs. So those actually are gone. So that's what we end up with for TU cross TV. Now what we're going to do is we're just going to do our dot product here. So we have our FRUV. So that means my first component's X, my second component's Y. So I'm just going to write those in. So for F here, I'm going to get sine U, cos V, comma, sine U, sine V, comma, 0. And then just plugging in for X and Y, and then 0 for Z, dotted with my TU cross TV. And then when we multiply those all out, we're going to get sine cubed U cosine squared V plus, I'm going to multiply the second ones here. That's sine cubed U sine squared V. And then for the third one, it's 0 times, so I'm going to end up with a plus 0, but I don't need to put that down. So then this simplifies because I can pull a sine cubed u out of both of those. And I'm left with cosine squared v plus, sine squared v, and that equals sine cubed u. So I'm actually going to do a double integral now here of sine cubed u. So double integral sine cubed u du dv. And we have to go back a ways and figure out what was our u. Our u was phi here. And again, we're doing the upper hemisphere here because the z is square root of 1 minus x squared minus y squared. So our phi is only going to drop down to the xy plane, so it's going to be 0 to pi halves. And then our v, which is theta, is going to go all the way around. So that's going to end up being from 0 to 2 pi. I should give myself a little bit more room over there. And plugging this in my calculator, again, we should be able to do something like this by hand, but it is what it is. This would be a substitution and peel off one of the signs there and introduce the 1 minus cosine squared x and go from there. But anyways, that would just be a u sub with a trig sub first. Or trig, I should say a trig identity. Anyways, it turns out to be 4 pi thirds. So there's our answer for this one here. So again, the biggest part is finding the RUV. We're getting better at just the cross product, TU cross TV. Hopefully that's getting easier for you guys. Well, there's our answer.